Hello, my name is Dave Burke. I'm an architect and a realtor for Exit Realty in the Bitterroot Valley in Montana. And the reason I'm going to produce this little video today is discuss how it is that buildings fall over, and in this case specifically pole barns, and how they fall over in uh, high winds. We've got a couple of examples of metal buildings collapsing, which is not the subject of this video. I'm going to spend most of my time on this talking about how wood frame pole barns can blow over in the wind, and I have some examples to show just that. A few months ago, there was a windstorm here in the Bitterroot Valley that caused quite a bit of damage to many buildings. This little building that you're looking at here uh, faced uh, towards another building that was actually blown over in the wind. But the reason I'm showing you this building is because it is very similarly built to the one that just blew over. And you can see here, I took a video of the inside, that this is a wood frame building with wood trusses. And although in this building there are sheeted walls in an enclosed space, in the building across the way that we're going to look at here in a second, the entire front of the building facing to the south, which is where the wind was coming from, was opened, which caused the damage we're going to look at here right now. This first photo is a general overview of the building that collapsed, and in the next few frames, I'm going to do a little bit of analysis of what I think happened. And again, this is my opinion. I'm not a structural engineer, I'm an architect. And I'm looking at this with a little common sense, trying to figure out what it is that went wrong with this building. So as we go through this, I'll try to explain my opinion of what happened and why it was blown down. Okay, in this photo, I did some overlays to see if I could sort of explain what happened. And the important thing to note here is that this building had a completely open front facing south directly into the wind. And in the realm of steel buildings and metal buildings and barns and that kind of thing, this is what's called a partially open building. And that means that the wind can blow in from one side, act like a windsock, and basically inflate and blow the building right up. And that's, I believe, what happened here. You can see the wind came in from the south, and it looks to me like the wind picked it up. And you can see on the right side there, it appears to look like an area of rotation where the wind rotated around that back corner of the building. And as it rotated, it sort of broke the back of the roof in the center. And you'll see in a minute how the rotation happened. But this allowed it to pick up, rotate, and collapse up and back to the back. And I think part of the reason for this is there was not enough lateral support in the north-south direction, which would have helped brace this building from the wind blowing in. And I don't think there was enough hold downs or strong enough members to keep the building on the ground. As you can see, the 6x6 posts in the front are broken and spun around and landed, a few feet away from where they started from. The good thing I note here is that the posts stayed in the ground, even though they broke off at ground level. That's a testament to the utility of buried posts. But the main thing here is I don't think there was enough lateral support in the north-south direction to keep this thing from being blown up. And I believe the weight of the roof and the trusses contributed to the disaster in the bracing, because the trusses are so heavy that when they were blown by the wind, the weight and gravity kind of helped it along in the collapse. These next three photos uh, focus on the posts, the two posts in the front of the building that were on the windward side, and the end wall on the west side of the building. And you can see, according to my little sketches and overlays, that first post basically broke off at ground level and leaned over to the left, or sort of went with the spin as the building spun over to the left. And the next photo again shows this column went almost straight back, maybe rotate a little bit to the left, but that would indicate that was on the other side of where the roof split open. So it went more straight back than it did rotating. And then this last photo is the end wall of the building that was sheeted. So it should have acted like a shear panel, and it sort of worked because you can see it came off in one piece, and it sort of fell all the way to the ground, but maintained its shape. So that tells me that when the building broke in half, or when the roof broke in half, this half of it sort of just went straight back, whereas the front half of it sort of twisted a little bit as it fell to the ground. So again, in summary, uh, the reason that this building collapsed was because it was a partially open structure, open to the wind, didn't have enough lateral bracing in the north-south direction, uh, and even though looks like it had sheeting, like metal sheeting on the end walls on the east and the west end, that was not enough to make up for the lack of at least I couldn't find any lateral bracing in the north-south direction that would keep the building from starting to sway and lean over, and that's what actually broke the post. So you can see on my little overlay sketches where basically the east end wall rotated and fell down onto that front post, and the building broke itself in half about halfway back, and the net result of the whole thing was a collapsed roof. So listen, in summary, uh, I have nothing against wood frame pole barns, but fact of the matter is, I'm a metal building dealer. Used to be a contractor, and I'm an architect, and I've done a lot of metal buildings. And the thing I like about metal buildings is that they are very lightweight and put together with steel, so they're very structural in nature, and it takes a really, really strong wind to get buildings to fall down, particularly when they're have an open side like this one did. As a matter of fact, when we do our engineering on partially enclosed metal buildings, we have to do a lot of extra screws in the roof to hold it down, an extra structure so you get that'll support the extra screws so that the building will stay together. Now, I'm not saying that metal buildings don't fall down. As I showed early at the beginning of this video, that metal buildings do fall down, and a lot of the reasons they fall down, mainly during construction, is because the main frames are not properly braced. The erector may be getting in a big hurry and not properly brace the frames off like they should. And particularly when you have larger span buildings, they will tend to get like spaghetti, and they'll collapse because the strength of a metal building comes in the ability to keep the main frames in a vertical, or in a vertical condition, so that the steel will attain its full strength and not fall over sideways. So again, you can see in these examples of metal buildings that the roofs are very light. You can put insulation in them, and it's very unlikely that you'll have a collapse as shown in this video, as I previously shown. So anyway, again, I'm Dave Burke. I'm an architect. I work with a realtor with Exit Realty, and I also sell metal buildings. You can call me anytime at 406-802-4577, and I look forward to working with you.